Hello everyone, myself Vinay Kumar M. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous videos, I have explained up to 14 questions. So in this particular video, I will be explaining the questions from 15 to 21. So now coming to the 15th question in this particular exercise, here they have asked to describe law of conservation of energy in case of a simple pendulum. So if you consider this as the simple pendulum which has been tied to this particular non-elastic thread and a bob. So in this simple pendulum, when you allow this simple pendulum to oscillate like this, so it will reach this particular position on the left side and it will reach this particular position on the right side. So here this particular simple pendulum is oscillating like this. So in this particular case, you have to explain law of conservation of energy. So when you leave a particular simple pendulum from this particular position, that means here initially the height of this simple pendulum was somewhere around this particular position, and now you have raised this pendulum to this particular height. So that means you have increased the height of this particular simple pendulum. So that means here you are giving certain amount of gravitational potential energy to this particular simple pendulum, or simply you can call potential energy. And from that position, if you leave that pendulum, it will start oscillating and it keeps on oscillating like this. So when the simple pendulum is oscillating like this, you have to explain how law of conservation of energy is maintained. So in this case, potential energy at these positions, so at this particular position, potential energy is maximum. So always remember, potential energy is maximum and kinetic energy is minimum. So kinetic energy is minimum and potential energy is maximum at the extreme ends of this particular pendulum, at this particular positions. So now when the pendulum reaches the middle position, that is this particular mean position, at this point potential energy becomes minimum and kinetic energy becomes maximum. So that means here at extreme ends potential energy is maximum, but at the mean position it is becoming minimum, and kinetic energy is becoming maximum at mean position and it is becoming minimum at extreme positions. So that means here the potential energy which is there at this particular point will goes on reducing and reaches its minimum value when it reaches here, and kinetic energy goes on increasing and reaches maximum value when it is at this particular mean position. So this is mean position. And at the extreme position, when again it goes back to its extreme position on the other end, again potential energy goes on increasing and kinetic energy goes on decreasing. So that means whenever there is increase in potential energy, there is decrease in kinetic energy, and whenever there is decrease in kinetic energy, there is increase in potential energy. So that means potential energy is going on decreasing and kinetic energy is going on increasing while reaching from extreme to mean position. So whenever pendulum is coming from extreme to mean position, the potential energy is decreasing and kinetic energy is increasing. But kinetic energy decreases and potential energy increases when the pendulum starts moving from mean position to extreme position. So that means here the potential energy and kinetic energy are increasing and decreasing, and thereby potential energy is getting transformed to kinetic energy, and again kinetic energy is getting transformed to potential energy. So that means here law of conservation of energy is maintained. So law of conservation of energy is maintained in this particular case. Here they have asked one more question in the same question, where if this particular pendulum is made to oscillate, it will not continuously oscillate. After certain time, this particular pendulum comes to rest. Why does this pendulum come to rest after certain amount of time. Why pendulum comes to rest? So why does this pendulum comes to rest? Why? Because here when this particular pendulum is oscillating through its mean position, at this particular time there is lot of gaseous elements present in our atmosphere and lot of air molecules are there in our atmosphere. Because of interaction of this pendulum with the atmosphere present around, hence this particular pendulum will face the resistance from the air molecules present around it. So there is lot of air molecules present around this particular pendulum. So because of these molecules which are present around this particular pendulum, hence this pendulum experiences resistance by these molecules present in the atmosphere, and hence this particular pendulum comes to rest after some time. So that means here the energy is getting transformed to heat energy, because constantly this pendulum is in contact with the air molecules which are present around that particular pendulum. So that means slowly energy is getting transformed to heat energy when this particular pendulum is constantly colliding with the air molecules present in the atmosphere. So that's why here energy is slowly getting transformed to heat energy, and hence after a while this particular pendulum comes to rest. But if you perform this same experiment inside vacuum where there is no air resistance, there this pendulum will be keep on moving for longer time without coming to rest, because necessary amount of potential energy is converted to kinetic energy, and kinetic energy is converted to potential energy, and again potential energy is converted to kinetic energy, and kinetic energy is getting converted back to potential energy. So these energy transformation keep on happening, and this particular pendulum will keep on oscillating for longer periods of time without coming to rest. But in practical case, if you are doing that in this particular atmosphere, if you are doing this experiment in an atmosphere, then here the air molecules offer resistance to the pendulum, and slowly the energy will be transformed to heat energy, and hence pendulum after certain time comes to rest. So this you can explain in your own words. Coming to the 16th question, here there is an object which has mass m, which is moving at constant velocity v. So here this particular object is moving with a constant velocity v which has mass m. So now if you want to bring this object to rest, how much amount of work has to be done? So here the amount of kinetic energy which this particular object is carrying is equal to half mv square. So EKI. So now this particular object, now it is moving at constant velocity v, and eventually this object should be brought to rest. So eventually this particular object has to be brought to rest. So that means initial kinetic energy is equal to half mv square. So half mv square is the initial kinetic energy. That means when it was traveling at velocity v, at that time its kinetic energy was equal to half mv square. Now this object, when it is brought into rest, at that time the final kinetic energy is equal to half mv square. So final kinetic energy will be equal to 0, because now this particular object has come to rest. That means there is no velocity. So if there is no velocity, then kinetic energy will be 0. So that means final kinetic energy is 0 and initial kinetic energy is half mv square. So in order to bring this object to rest, how much work has been done? That you have to calculate here, and we know that work done is equal to final kinetic energy minus initial kinetic energy. So what is final kinetic energy? Final kinetic energy is 0 and initial kinetic energy is half mv square. So that means here work done is equal to minus half mv square. So work done is half mv square, and this particular minus sign indicates work done is negative. So here minus sign indicates work done is negative, because work is done in the opposite direction to the motion. That's why this object has come to rest. So this negative symbol indicates that work has been done in opposite direction to the direction of motion of the object. So half mv square is the work done to bring this object into rest in the opposite direction to the direction of motion of this object. Coming to the 17th question, here they have given the value for mass and the value for velocity. So here also you should calculate work done. So here there is a particular car which was traveling at 60 km per hour velocity. So its velocity was 60 km per hour initially, and the mass of this particular car is equal to 1500 kg, and this particular car has brought to rest. So initially it was moving with velocity 60 km per hour. So after a while this particular car has brought into rest. So that means initial kinetic energy of this car is equal to half mv square. So initial kinetic energy is equal to half into 1500 into velocity. You have to convert that into SI units. So now, as of now, I'll just write v square. So first we will convert velocity into SI units. So velocity is equal to 60 km per hour. So now if you convert this to meter per second, you have to multiply this with 1000 and divide with 3600, so that you will get meter per second as your SI unit for velocity. So here 0 0 0 0 gets cancelled with each other. Here 6 ones are 6, 1 0 will be remaining, 6 6 are 36. So 10 into 10 is there. So 10 into 10 is 100. So 100 divided by 6 meter per second. So initial kinetic energy is equal to half into 1500 into 100. V square is there. So in the place of V square, 100 by 6 meter per second whole square. So now you can calculate the initial kinetic energy, that is equal to 1 by 2 into 1500 into 100 into 100 is 10,000 divided by 6 is there, 6 square is there, so 6 square is 36. So now you can calculate this. So this can go with 2. So 2 ones are 2, 1 is remaining, so 8, 16 will be there, so 2 8s are 16. So here also this can go with 2, so 2 7s are 14, 1 will be there, so 2 5s are 10, 0. Again this can go with 2, so 2 9s are 18, here also it can go with 2, so 2 3s are 6, 1 is remaining, 15 will be there, 2 7s are 14, so 1 will be remaining, 5. So 375 by 9 is there. So 2 lakh, after calculating this, you will get answer as 2,08,333.33 joules. So what is the final kinetic energy? Final kinetic energy is 0. So now you have to calculate work done. So work done is equal to difference in kinetic energy. So now EKF minus EKI. So what is initial final kinetic energy? 0 minus 2,08,333.33. So work done is equal to minus 2,08,333.33 joules. So now you can just consider the magnitude of work done, that is equal to 2,08,333.33 joules, where this negative symbol indicates that work done is acting opposite to the direction of motion. That means work done is negative in this particular case. So coming to the 18th question, here they have given 3 different cases, where in the first case force is acting in this particular direction and the direction of motion of this particular object is in this particular direction. So that means force is applied in this direction and displacement of this object is happening in this direction. So here work done is 0. And in second case, force is acting along the direction of displacement. So the object is getting displaced in this particular direction and force is also there in the same direction. So in this case, work done is positive. In the third case, here force is acting opposite to the direction of motion. That means if the object is displacing in this particular direction, the force acting on this object is applied in the opposite direction. So that means here work done is negative. So here the answer for this 18th question is, in the first case work done is 0, in the second case work done is positive, in the third case work done is negative. So coming to the 19th question, here there is a student named Sony who is telling that when an object is not having any kind of acceleration, still there can be external forces acting on it. So that means here, even though external forces are acting on an object, still the object can have zero acceleration. Because we know when a particular force is applied on an object, it creates acceleration for that object. So here force is directly related with acceleration that we have learnt in Newton's second law of motion. But even though there is external forces acting on an object, still acceleration of that object can be zero. How that is possible? So if there is an object like this, so if this object is experiencing a force, a forward force, and if this object is experiencing an equal and opposite backward force, so that means, let's say there are two different forces acting on this object. One is F1 and one is F2. So F1 is the force acting along the direction of motion, and this object is moving in this particular direction with uniform speed. So if this object is moving with uniform speed, means there is no acceleration. So here this object is traveling at uniform speed, that means acceleration is zero. So in order to maintain this uniform speed, there is certain amount of force F1 acting on this, because there is certain amount of drag force which is acting opposite to the direction of motion, which is F2. So here if F1 is equal to F2, so here I am considering the magnitude of forces F1 and F2. If they both are equal, then this particular object will be in uniform speed and acceleration is zero. So that means when a particular object or a particular car or a particular vehicle in which you are traveling, if it is maintaining uniform speed, means constantly there will be certain amount of frictional force acting on that object, and there's various other forces acting on that particular object. Still the car maintains to be in uniform speed, because the acceleration pedal which the driver has pressed, that is giving necessary amount of force which is equal to the drag force, which is applied in the opposite direction to the direction of the motion of that particular vehicle. So that means force which is responsible for the forward motion and the force which is acting opposite to the direction of motion, both are equal. So when both are equal, that particular vehicle will travel at uniform speed. So that means all the set of forces which are along the direction of motion and all the set of forces which are opposite to the direction of motion, when they are equal in magnitude, that means set of forces along the motion and set of forces against the motion, if both these are equal to each other, then that particular object remains at rest or it remains at uniform motion. So in this case there is no acceleration, so that is acceleration is zero. Coming to the 20th question, here there are 4 devices where each device has power rating 500 watt. So that means total power including all 4 devices. So I am taking total power of all 4 devices. So that will be equal to 4 into 500. So the total power is equal to 4 5s are 20. So that is 2000 watt. And all these 4 devices has run for 10 hours. So that means here they have given time also, that is equal to 10 hours. So now you have to calculate the total energy spent by all 4 devices. So now the total energy is equal to power into time. So what is power? Power is 2000 watt. I am considering all 4 devices, into time is 10 hours. So in the place of hours, I can write seconds by multiplying 3600. So 2000 watt into 10 into 3600 seconds. So 3600 seconds. So 2000 into 10 into 3600 is equal to, so 36 into 2 is 72. So here 3 zeros are there, here 1 zero is there, here 2 zeros is there. So 6 zeros I have to put here. So watt second. So watt second I can write this as joules. So 7.2, in the place of writing 72 in followed by 6 zeros, I'll write 7.2 into 10 power 7. So here I have moved the decimal point from this particular position to this particular position. So after 7 digits I am moving that particular decimal point. So that's why I'm putting here 10 power 7. So 7.2 into 10 power 7, in the place of watt second I can write joule. So the total energy spent by all these 4 devices when they were run for 10 hours is equal to 7.2 into 10 power 7 joules. Coming to the 21st question, here a particular freely falling body, when it hits the ground, what happens to its kinetic energy? So what happens to kinetic energy when this particular freely falling body hits the ground? So when this freely falling body hits the ground, this particular kinetic energy at which that particular body is traveling with. So because when a freely falling body is falling from certain height, that means its potential energy is getting converted to kinetic energy. So where does that kinetic energy go after that particular ball has hit the ground? So this kinetic energy has been converted to heat energy and sound energy. So here kinetic energy is getting converted to heat energy and sound energy when it hits the ground. So that means here kinetic energy has got transformed to heat energy and sound energy in this particular question. So this is all there in this particular video. This comes to an end for work and energy chapter. So like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.